Again, the topic is National Weather Service Web Resources, and we're referring to primarily the Internet resources that we have available. I am speaking on a headset, so again, I'm not sure how it sounds at your end, but if you hear any popping or excessive noise at my end, please let me know, and I'll readjust the little microphone at the end of this headset.
Will do.
Now, I do have probably about 50 to 55 slides. Many of these we can just zip right through. I also have on a screen, adjacent screen, live web pages that we could refer to at any time, so we can provide examples, step-by-step interaction, so you can see how these web pages work and the various resources that you'll be able to access after we've had a chance to just kind of briefly touch upon this. So what I'd like to do, again, feel free to stop me at any given time. We are currently in the process of recording this presentation, so Corey Pieper, IT rep here at the regional headquarters, is going to be able to provide this, make this available later on, I guess, where we can go back and access the data. So we'll see how that all works out. I know he worked last night on this, so hopefully the system is working like it's supposed to. So with that said, can you all see the center screen that says NWS Web Resources?
We sure can.
Okay, great. Let me go ahead. We'll start off with a quick overview. I was just, for all the people that are on the call right now, many of you may not be fully aware of how the National Weather Service is structured, especially the local weather forecast office. So we'll do a brief background on that, and then we'll go into the meat of the presentation, which will be the NWS web links from a national perspective down to regional, then local, and then also our specialized centers that we have that provide a plethora of data that just really, you can spend days, if not years, going through. But we want to just be able to touch upon the things that I think that you might be able to use more effectively in your daily business that that they provide continually. And if you can look at the National Weather Service as a big production line, we are producing just mountains of meteorological information, both on a text format and also in a graphical format. And the information comes out on a scheduled basis, day after day. But there's also data that is non-routine, and that information is sent out on a more as-needed basis. But generally speaking, I would say the bulk of the data that we produce is all scheduled, and you can rely on that information being there consistently, day after day, hour after hour, from the respective different web links. And finally, we have a couple of things. I just wanted to show the differences between some of the text-based data and the graphical information that we have. And following up, like a brief note on Jetstream. This is our weather education resource that Mr. Dennis Kane, who worked here at the regional headquarters for multiple years, had worked on. It's an excellent, a very well done, interactive weather education resource, and we highly recommend it to anybody that wants to learn a little bit about the weather, whether it be at school age level all the way up to adult level. It's very well done. Dennis was very creative in taking sometimes what we call very complex meteorological situations and conditions and translating them into the most common denominator so that the average person can fully understand and wrap their brain around. So meteorology is one of those kind of things. It's a very complex science, and in the world of weather, we try to do the best we can to translate that so it has value to the average person so they can understand it without having to have a degree in meteorology or really anything more than just a basic understanding of science. So with that said, let's move on to our next slide. A little history. The National Weather Service has been around since 1870. We are a federal agency. If you want to look at where we stand in the pecking order of government, if you kind of relate it to a child, mother, father, then grandparent, we are basically the child of NOAA, the National Oceanic and Atmospheric Administration, and the Department of Commerce is the grandparents. So it's Weather Service at the lower level, NOAA is the parent, and above that is Department of Commerce. Again, President Grant, back in 1870, established the Weather Service. There was a real need for it because at that time, two of the big drivers in our national economy was agriculture and shipping, and we were losing a lot of our tonnage was shipping tonnage was lost at sea due to the weather elements that at that time just were not forecastable. We didn't have satellites in space. We didn't have radar near the coast. We had no real ground observing system to provide mariners information on what they could expect when they're transporting goods and services. Same thing with the agricultural component. We never really had a good database on climatic information to find out when might be the earliest you could possibly plant crops, or what might be the latest period of time due to potential freezes. So we needed to have some sort of observing network to help with develop a climatic base. So Grant understood that, and he also during the war realized the importance of weather information and how it impacted military operations. So basically the Weather Service is there to save lives and promote commerce. That's our basic mission. And when we look at our structure as far as National Weather Service offices, this particular map here shows the Weather Service offices' areas of responsibility across the nation. There are 122 distinct and separate weather offices, and each one of those colored areas with the three-letter ID is that particular weather office in the area that they provide warning forecast services for. There are 6 Weather Service regions, but most importantly, it's the Weather Forecast Office that does the bulk of the actual production of weather information that you see in your nightly news or hear on radio, or when you search the web, no matter if it's a government website or if you're looking at a private website, that information for the most part is coming from your local National Weather Service office. There are typically about 25 people that work at a Weather Service office. There's typically 5 to 10 meteorologists that actually work the operating shifts. We have typically 2 people on per shift, 2 meteorologists per shift. We have 3 shifts per day, 7 days a week. There's no holidays, there's no weekend parties or nothing like that. There's always someone there at the Weather Service office monitoring radar, releasing weather balloons on a scheduled basis, monitoring a whole host of ground sensors, satellite data. We transmit this information through a wide array of dissemination systems, including the weather radio transmission, and that's been around for a long time, close to 40-plus years. It started off humbly as a small service up in the Great Lakes back in the 60s and early 70s and spread nationwide. We currently have well over 1,000 transmission sites across the nation, and we also even provide that information via podcast. So it's available for just about any location in the country. I think we currently service well over 95% of the nation has access to the weather radio signal, again, across the nation. So it's quite an achievement where you can receive continual flow of weather information nonstop 24/7 via a designated and specified broadcast for weather information only, and also receive weather warning information around the clock. It's just a great service. Again, as I noted before, the 122 weather offices nationwide deliver the major part of the National Weather Service mission. Now, going into the websites, we have national, regional, local, and specialized center websites. The one I want to really kind of focus on immediately is the weather.gov. Weather.gov is our National Weather Service primary website. And what I have here is a snippet or the front page for the most part of what you see when you go to weather.gov. This is a map of the United States, county breakdown, and it's a hazards map. And the hazards map is designed to provide the user the opportunity to look at any location across the country and in one snapshot see where all the meteorological hazards are occurring or are forecast to occur across the nation. Now, there's multiple different ways you could look at this. You can say, well, what if I want to find out what's going on up there in the northern tier states, up there in Minnesota, North Dakota? There's an area of purple, and hopefully you see that your end is purple. And can you all see that, by the way?
We sure can.
All right. You can say, well, what is that designation of color up there? So if you look at the tab on the upper left-hand side, it says active alerts. And you can access the information specifically for that particular area in purple through multiple ways. You can directly click on the center of the screen and any one of those counties highlighted by purple, and that will redirect you to a text product that tells you specifically what is in effect. Or you can look at below and say, well, what is that? It's a winter weather advisory in purple, and you can click on that winter weather advisory I've highlighted in that red oval, and that will then redirect you to the text product for that geographical area. Now let's say that we go to our next tab on the upper left-hand section of the weather.gov main page. We take a look at forecast maps, and we click on that, and that will then redirect us to a whole host of various weather maps for the nation from the Weather Prediction Center. In this case here, we have our national maps, very similar looking to what you might see on your local weather forecast television station. You can click on those particular graphics, whether it be the national map, the digital forecast maps, precipitation maps in the lower left here, analysis maps, and get a whole range of graphical information going out multiple days. Now let's say we click on radar on the upper tab as highlighted in the red oval. That will take us to this image showing a national mosaic of radar data. Again, this is being collected from well over 100 plus radars nationwide, all mosaic together to provide you this national image. Now the national image then can be also looped, or you can drill down to a smaller subset, and if you look below, you'll see these thumbnails. These are regional thumbnails, and you can then get more of a regionalized image of radar data that we are collecting. Again, these are radars that are mosaic together, pieced together, kind of a patchwork, to come up with one singular image. And in this case here, we can see the shower and thunderstorm activity from back in March or February of 2006 as it impacts parts of Alabama, northern portions of Georgia, and of course the main thing we're looking at here is the state of Florida with the shower and thunderstorm activity basically impacting virtually the entire state, all the way from the Keys northward into the Ocala-Gainesville area.
And
go ahead, I'm sorry.
Quick question for you, Walt.
Yeah.
So we're looking at the radar, and what time period would this represent? So is this over a 12-hour period?
This is a short, usually about an hour, 45 minutes to an hour, and if you kind of look at the lower left here, you can see the time frame in universal coordinated time. It's approximately an hour. When you look at it, then you drill down to the next level, the weather forecast office level. These loops are generally about 45 minutes or so, and they're about 4 to 5 minutes per frame. The radar, local National Weather Service Doppler radar, produces a multiple slice cut of the atmosphere as it rotates around every 20 seconds, and it takes about 4 to 5 minutes to do a complete vertical sampling of the atmosphere. So if you could picture the radar basically rotating around on its pedestal every 20 seconds, after about every third revolution at a particular elevation slice, it moves up to the next elevation slice. So it's taking slices of the atmosphere, and then what we then do is we package it all together, and we get a three-dimensional picture of the atmosphere. One composite image, again, takes approximately 4 to 5 minutes to produce that out of when you take all the slices and put it together.
Within the map. Gotcha.
Okay. Again, looking again at a regional picture, this was yesterday evening, probably around 7 or 8 o'clock in the evening, and we can see we had shower and some isolated thunderstorm activity over Oklahoma, really from Oak City all the way down to just northwest of the Dallas-Fort Worth metropolitan area. Now let's say that you're looking at the regional image and you say, well, what's really going on in the Oklahoma City area? You can click directly right over any location near Oklahoma City, and it will pull up the closest radar to that click. So let's say I went back and I'm halfway in between, maybe driving up from Dallas-Fort Worth and I'm up around Ardmore, Oklahoma. So then wherever I click will determine if I get the Dallas-Fort Worth radar or the Oklahoma City radar. So whichever one is the closest is the one case, I was a little bit closer to Oklahoma City. I clicked around Ardmore, Oklahoma, and the Oklahoma City radar displayed from the local office. And then as you get into the local office settings, you can then loop, zoom, you can pan left to right, north to south, and you can look at additional radar imagery other than what we were looking at, what we call here the reflectivity image. You can also look at what we call velocity data. Now, for your purposes, I would say the velocity data, it's nice to know, it's nice to have, but that's really, it's more of an instantaneous tool used by meteorologists to help detect wind areas within a thunderstorm that might be precursors to tornadic development, and that what we would typically use for issuing severe thunderstorm or tornado warnings. Well, I guess maybe in the scope of what you're doing, you're looking more of a broad picture,
Yeah.
and so that it's more of a nice to know type information for yourself. But I've always told people that when you look at velocity data for radar, it's more of a meteorologist type of diagnostic tool, and it has you really have to know radar in order to use that tool properly. But we do make it available. Now, going back to the national page again, on the upper tab it says satellite. We have an opportunity to look at satellite imagery across the nation. And when you click on that tab, it brings you to this particular link that allows you to click on satellite imagery that's in 3 different channels that we use. The satellites in space, the weather satellites, produce imagery in multiple different what we call light channels. But the ones that we try to provide for the public that are of the most use for the public are primarily the infrared, the visible light, and the water vapor. And to kind of give you an idea, vapor imagery is typically used for viewing the upper level of the atmosphere, where we can see flow patterns and so forth in a little bit more concentrated manner than we could with other imagery. So it's a very useful tool to really kind of get a perspective of these large weather systems. And what we're looking at in this upper center screen is a vapor imagery, satellite vapor imagery of Hurricane Katrina back in 2005. Very well defined hurricane with a very nearly perfect eye as far as its concentricness, and we can see the flow out around the hurricane, and quite massive as far as its overwhelming impact. But again, this is upper level, so what's happening down at ground level is really concentrated in this narrow area around the immediate eye. So again, satellite imagery again requires a level of interpretation, and you have to use it with caution. Infrared satellite imagery allows us to look at weather features during the nighttime hours, and the way this particularly works is we're not really looking at the visible light. We are looking at the temperatures of the clouds, and we take that temperature and convert it to a color. So we really can't see what's going on at night visually, but we can take the temperatures of the clouds, translate them into a color code, and there, as we see in this right center screen here, a beautiful display of Hurricane Katrina. And what's neat about using infrared imagery, it allows us to hone in on the more intense portions of the weather hazard. In case if you look at the lower bar here, the colors correspond to temperature, and typically the colder the temperatures of the clouds, these are much higher in altitude, which then correlate that the storm is probably stronger in those locations. So the higher the thunderstorm clouds, the colder the temperatures aloft, correspondingly usually equate with more intensity. Typically during the daytime hours, the satellite works very much like a camera, just like your hand camera that you might have to snap away pictures of your family. It's basically you can take a black and white picture from outer space looking down at the ground, and this is what you would see. And this is the visible satellite imagery, high resolution, used primarily for daytime viewing. Now that we get into the regional, let me go back. Are there any questions on anything I've discussed thus far?
I don't have any. Anybody from the team? I think you're doing great. Well, thank you.
Okay, again, just jump on in if there's a question, and we can always go to a live interaction. I have, again, the web page is all set up on another screen next to me here, and we can pull those over and we can do some clicking. If you want to reserve that for the end, that'd be fine also.
Right now, we'll hold off on our questions unless there's something we need.
Okay. Now, drilling down to the regional web resources, this is from the Southern Region headquarters. This is our web page of the National Weather Service, and when you go to this link, srh.weather.gov, you'll come up with this image, which starts off with a graphic of the United States, and again, the local weather forecast office areas of responsibility are displayed. You can access local forecast and warning information in two ways. You can go to this little window here in the upper left-hand corner of the margin, and in this case here, you can put in your zip code, you could put in a city, state, or you can click on a specific point on the map, and it will automatically drill down to the local forecast and information for that point. In this case here, I put in my zip code, 76182, and what we get is the local weather forecast page specifically for my location, in this case, North Richland Hills, Texas. And yesterday evening when I crafted this up, it was about 54 degrees. We see the current information located right here. But let me kind of point out the areas to really focus on, because this is important no matter where you're at in the country, no matter which weather office you click on, this display will look the same. So if you access, for instance, you wanted to find out what weather information might be in New York City, from the Southern Region web page, you click on that map location. Again, we go back. If you click in New York City, your weather forecast information for that point location will look just like this. If it's Seattle, it would be the same way. If it's San Diego, it's going to look like this. So in the upper left-hand corner, the most important thing we try to display initially is, are there any watches, warnings, advisories in effect? That will show up in this block. You just click that link, and they'll provide you in text format what the watch, warning, advisory, or statement may be. Current conditions with an icon and temperature and other meteorological parameters are located just below that. Then, for a quick visual reference, going out 5 days, are forecast icons that provide you what the weather conditions are expected for that time frame, along with the probability of precipitation, the high and the low. Now, we are going to be making changes to that here in the not-too-distant future. We are going to be adding some color coding that will go around the particular time frame when there is a watch, warning, or advisory in effect. For instance, watches will be in yellow, advisories will be in orange, and warnings will be in red. That will help provide a more visual recognition of any type of inclement weather hazard that might be expected multiple days out on the horizon. Now, below these forecast icons is a detailed text description going out 7 days of the local forecast for your specific geographic area. Again, this is just more in-depth information for people that want to see what the specifics are, winds, temperature, meteorological conditions, in more of a expanded format. Some of the most popular information that people have a tendency to derive and grab onto is the radar, again, satellite information, and that's in the lower right-hand corner, and also the weather timeline, which is a great little tool if you want to find specific information on a number of meteorological parameters on an hour-by-hour basis going out 3 or 4 days at least. So a great tool if you want to look at trends. Okay, we go to now our specialized weather centers. And I think this is going to be something that you're probably going to be most interested in, and it might have greatest application to what you're maybe looking to do. We have multiple specialized weather centers. I think there's 7 of them now, 6 or 7. But I'm going to hone in on just the 4 that really provide a lot of graphical information about hazards in the short, intermediate, and long term. the one that you're probably most familiar with is the Storm Prediction Center. They're tasked with providing specialized services in the severe weather area on a big picture. I've circled here, for instance, the severe weather outlook for day 2. So let's say that this is what it would look like when you went to the Storm Prediction Center, spc.noaa.gov. You would click on, for instance, if you're interested on what type of severe weather might be occurring on day 2. And in this case here, you would see this graphic would show up showing that there's a slight risk of severe thunderstorms from central to south Florida, mainly along and south of the I-4 corridor going down towards just down around just north of the Keys, maybe Marco Island, all the way up towards just south of Melbourne. And the green area would be just generalized thunderstorm activity, typically below severe thunderstorm limits. To the right, I've shown just for demonstration purposes, is the text information that goes with this particular graphic. Typically, this text would fall just below it. And some other information that's important here on this graphic is the Storm Prediction Center has, over the last couple of years, started including if there is a risk of severe weather. If you look at the lower bar here, at the very bottom of the graphic, you'll see the risk level is slight. They'll tell you, for instance, the geographical area in square miles covered by the slight risk area, the amount of the population that is potentially impacted. So 5.5 million people impacted by this severe weather threat area. And that has a lot of impact. That has, it seems to be catching the ear of a lot of people in the media when they it kind of gives them another diagnostic tool to kind of provide people about the level of urgency and the amount of population affected. It seems to be very popular with the media. The population centers that are impacted in this risk is also described here. So again, it gives people that may not be familiar with geographics a quick reference to see what population centers may be impacted by severe weather going out down the road. The Weather Prediction Center, WPC, wpc.nsep.noaa.gov, provides probably the greatest number of graphical maps that is used by the broadcast media, and you have access to that. And let's just kind of look at one in particular. If we look at the legend on the left, we'll see the winter weather graphics. And when we pull that up, for instance, we have a capability to select from a wide array of forecasts for snow, sleet, and freezing rain on a national level. The maps are available in standard JPEG format, or if you want, in GIS format. You can. This is an interactive map, and you can, for instance, look to your right, and you can say, how much snow? Say, what's the possibility of 1 inch or more of snow over a particular time frame? So you can, for instance, in this case here, I selected 1 inch. The grid. What's the possibility of one or more inches of snow across the United States? What's the probability of that for a particular time frame, a 24-hour time frame? I selected ending at 12 Zulu, March 7th. In this case, that would be 6 a.m. On March 7th. So if you look at the graphic, the northern tier states, right along the Canadian border, there is well over a 90 to 95 percentile probability of snow in these areas, at least 1 inch. But a little further south, in our area is concerned, let's look at the southern Appalachians of Tennessee and North Carolina. And typically speaking, it's a pretty good bet anytime you get more than 50% or greater. This is a very useful graphic to kind of give you an idea that you're going to get snow. So I always like to use that 50% or more as a determining factor that you most likely will get snow. 50% or greater is a pretty good threshold. And you can then select on any one of these parameters. You could go to 8 inches, or you can select a time frame, and the graphic will be produced for whatever you've selected. You can also zoom in to a state or a region, and you can produce snapshots if you like, or you can do a screen capture or a snippet cut, and you can graphically grab onto that image. lot there. Here's another graphic that's very popular. Is the precipitation forecast in various time intervals on a day, 1, 2, 3, all the way out to 7 days from the Weather Prediction Center. In this case here, there's a large bullseye of rain forecast just off the Louisiana coast, going to be primarily impacting Flipper and his friends, but further north, it looks like the forecast amounts are much less. We can look well to the northwestern coast of the U.S. You can see up there around Seattle, well over 4 inches of rain forecast. Down to the Northern California coast, about 3 inches plus. Looking at our next national center, the National Hurricane Center, nac.noaa.gov. Not much graphic activity right now, but this is what you would typically see as soon as you went to this main homepage of the National Hurricane Center. You'd be able to select either the Eastern Pacific or the Atlantic to see the tropical cyclone activity forecast for those various oceans. And on the left-hand side of the screen, you'll notice typically all our Weather Service web pages have a left margin where you can select particular types of information. In this case here, cyclone forecast, marine forecast, various other tools and data such as satellite radar information, analysis tools. One of the areas that I'd like you to kind of take a look at is the data archiving. There's a lot of great information about past tropical cyclones that you can pull up graphical information along with text data if you need that. So it's a great tool to fall back on for information that you might want to produce for, say, a PowerPoint presentation of what is the probability of, for instance, tropical cyclones during the month of September over the western Gulf of Mexico. And you can find that information there. Or what is the reoccurring chance of a Category 3 over the northern panhandle of Florida, again, for a Category 3 storm. That information is produced and provided there in graphical and text format. The last center I'd like to talk about is the Climate Prediction Center. Again, they provide a whole host of climatic information, and let's just say, for instance, we wanted to take a look at the projected outlook of temperatures on a 6 to 10 day basis across the United States. We can then click on the 6 to 10 day. Again, that's in the oval here, 6 to 10 day outlook. In this case, we're just mainly concerned about the temperature, but here's an outlook, the probability of below normal temperatures or above normal temperatures, in this case, for the period March 11th through the 15th. The dashed lines in this particular map represent the normal temperature. That would be the normal temperature, which would be the average of the high and the low combined for this particular period of time. If you were looking at Tallahassee, the normal temperature would be around 60 again. You might have a normal high of 72 and a normal low of 52 to come up with that basic average. But generally speaking, the below or the above is reference to these normals. And it looks like the Great Lakes, again, all the way back in New England, will be suffering through another cold period. No break for them this winter. And, of course, looks like the far west is going to continue with well above normal wintertime temperatures that they've been experiencing this year. Now, we have a lot of products and services on the tech side. Every weather forecast office provides a plethora of text information. Just a kind of a quick rehash for those that may not be familiar with, again, our terminology. The National Weather Service issues watches, warnings, and advisories. Watches means the conditions are possible. For instance, there may be the possibility of freezing rain, sleet, or snow in the distance. It might be 36, 48, 72 hours in advance. These text products are issued and updated every 6 to 8 hours. Basically, the idea of the watch is to inform people to be ready for the next phase, which would be either an advisory or a warning. Warnings are issued when the severe weather threat has been either observed visually or detected by weather radar. Now, we're talking about short fuse warnings like tornado and severe thunderstorm warnings. These are typically issued, they'll cover portions of multiple counties or a single county A polygon, as we call it, might be a kind of a, if you could picture a fan-shaped graphic that is covering the initial location of the threat, and then the fan basically moves in the direction that the threat is projected to move based on our radar observations. And again, that fan may cover, or what people call a polygon, may cover, again, a portion of a county or multiple counties themselves. Typically, these short fuse warnings are valid up to 1 hour. Their typical ranges of valid time are 15 minutes to 45. The tornado and severe weather statements there are to update the warning and progress, and the idea of the warning of the statement is to provide one, validation of the hazard that's currently that's impacting the community, and update for the media and the public, emergency management, about how that hazard is transitioning. Is it dissipating? Is it intensifying? What kind of reports do we have validating that this particular threat is really occurring? So the severe weather threat is basically, severe weather statement is basically a play-by-play action of an ongoing event. Local graphic cast. Our weather offices have been expanding the graphical capabilities at a rapid rate, and although we have not settled on a particular standard yet at this time, we're still relatively experimenting with graphical capabilities at the local level, because there's so many different ways of presenting information, and there's still we're learning and trying to find better ways in which to, again, present information on a localized level. Give you some examples of some ideas that we've been throwing out there and we've been putting on our local web pages are these graphical images of that are similar in design to many of the media graphical pages that you see on your nightly news. Here's one from Oklahoma showing the potential of snow, freezing rain, and rain. Here's an example of just cool and dry weather forecast for a Thanksgiving period over Oklahoma, with highs and lows forecast, along with the potential of wind. Here's another one here showing the Thanksgiving Day forecast for the Fort Worth, for the San Angelo area of responsibility. Again, mainly concerned with their area. Here's another graphical map from that same weather forecast office showing the potential of a low-pressure system that's going to be impacting over a particular period of time, and the areas of forecast snow and rain and so forth. Again, more graphics. And here's another one showing the potential of snow for the Dallas-Fort Worth area and areas east and west along the I-20 and I-30 corridors across North Texas. And again, you can get the idea. There's a lot of different ways of presenting weather information, and it varies from office to office at this time. Again, we are in the experimental stages of producing these type of low-level graphical images. Here's a case of trying to depict the severe weather threat of potentially a line of severe thunderstorms that might move across portions of central Alabama, giving people more of a timeline potential. And this kind of information is very important for emergency management and the media, because when you think about that, you have ongoing daily operations. People are moving about. You have people in school. You have people at work. When do you release people where you don't have a tremendous over impact on the economic base of a community? How do you minimize disruption to a community? So we're looking at ways of providing these graphics that provide a little bit more value-added information, so decision makers can be more effective in what they eventually decide and place on the community as far as the decision. I like these graphics. They're a little bit more, have a more of a professional media quality about them, and this comes from our forecast office in Little Rock, and again, we're looking at ways to emulate, not reinvent the wheel, but emulate and produce graphics that really have value for for the public, emergency management, the media, and other users of this data. I'm going to briefly go through this part here. This National Weather Service digital products. We spend a lot of time producing what we call digital forecast information on a national level, and some of the products look like this. This is a high temperature forecast based on a grid of grid points across the nation, where we actually populate very discrete little points on a map with data. So when you put it all together, you have a much more fluid graphical display of information. Again, this is a temperature forecast from back in 2007, kind of more of just to give you an idea of what it would look like. The low temperatures forecast for the nation back in 2007, based on the digital grid packages that our forecast offices put together, and then all that information is then stitched together to come up with these mosaics. And here's a kind of a digital forecast at state level. And you can see how that has a variance from one end of the state to the next. Of course, Texas being a big state, you can have some tremendous variances. 50, 60, 70 degrees is not uncommon. And here's more of a local look, showing forecast winds along with temperatures. This is a hazards graphic. The last thing I want to touch upon is our Jetstream educational webpage. Again, just tremendous amount of information that is designed for the average person who has an interest in weather, where they can go in a kind of a course-like manner. You know, the legend on the left-hand side of the screen shows the various topics, and you can go through those topics. The information is designed to be user-friendly, very easy to digest. You don't have to have a degree in meteorology to understand this. Again, it's designed to provide a very, very basic understanding of meteorological concepts and ideas for the average person. And again, rounding out, these are just some web resource links of the primary pages that we've just gone over. The National Weather Service page, again, is weather.gov. The Southern Region main page is srh.weather.gov. And the key thing to look at all these pages to know if you're on a national government website is at GOV. Of course, that is the big kicker. And we strongly recommend that you look at our pages simply because virtually all the weather data, forecasts, watches, warnings, advisories that are generated for the United States come directly from the National Weather Service. And our friends in the media and the private sector, they take a lot of our data and they add value to it. They provide it to specialized services and things of that nature that is beyond our scope. But generally speaking, if you're watching your nightly news, or if you're watching even the Weather Channel, that information is the base data. It all comes from the National Weather Service. That rounds out my presentation.